Welcome to Mathematics for Principles of Economics. The topic of this video is what happens when supply and demand curves shift.
And the math behind the economics is shifting curves.
So let's look at this supply and demand graph and say this is for a product such as candy bars. We note the equilibrium price and quantity. So what will happen if either the demand curve changes or the supply changes or both?
In order to understand that question, we need to understand how the graph of a function changes when the function itself changes in certain specific ways. For example, what if you have a function y equals f of x, and then the function changes so that instead of just f of x, you have f of x plus 2. This would happen if you have a constant change in your function that doesn't depend on the input. So you're just adding 2 no matter what. Or, for example, maybe you start with the function y equals f of x, and then the function changes so that instead of f of x, you have f of x minus 2. This would happen if you have a constant change in your function that does depend on the input, because we're inputting x minus 2 at a certain point instead of just x. So let's see quickly what happens geometrically in both of these situations. So what if my original graph is f of x equals 2x? Well, if x equals 0, y equals 0, so I have this point, and if x equals 1, y equals 2, so I have this point. So the graph of this original function then, f of x, is just this straight line. Not looking so straight, but the best I can do. Okay, and so then now let's look and see what happens when we change it so that instead of just 2x, we have 2x plus 2. Now when x equals 0, y equals 2. So I've shifted my graph up by 2 units. And when x equals 1, y equals 4. So again, I've shifted that value there up by 2 units. And my new graph is a parallel line, same slope, slope is 2, and the graph has simply shifted up by 2 units. Let's try the second one now. What if I have the function f of x equals x squared? That is a parabola that looks like this. If x equals 0, y equals 0. If x equals negative 1, y equals positive 1. And if x equals positive 1, y equals positive 1. So it's just a nice parabola like that. What happens now if I change my input in the following way? So now when x equals 2, y equals 0. So this point here shifts to the to the right by 2 units. When x equals 2, y equals 0. And when x equals 1, y equals, so if x equals 1, y equals if x equals 1, y equals negative 1 squared, and so y equals 1, so I get this point here. That's shifting this point 2 units this way. And if x equals 3, y equals 1, and I get this point here, that shifted this original green point, which is now covered up this direction too, and my graph looks like this. So my whole parabola has shifted to the right by 2 units because of the change in input.
Okay, let's answer the question about supply and demand graphs. First of all, let's note that with this demand curve, if the price changes from, say, $4 to $3, we don't need to shift the curve. We just move along the curve. And that's because price is measured on the vertical axis. So we see the change in price along the given demand curve. And we call this a change in quantity demanded. Okay, however, if something happens other than a change in price which causes the whole curve to shift, then the demand curve is going to move to the right or the left. Here we see an increase in demand because at each price consumers are purchasing more of, for example, candy bars. Okay, now noting the underlying functions shown in the table for the 2 demand curves that we looked at, we notice that there was a parallel shift in the demand curve because at each price, quantity increased by 3 units. So these are the numbers that underlie the demand curves that you saw. Okay, if we put the new demand curve together with the supply curve, we note that the increase in demand causes the equilibrium price to go up and causes the equilibrium quantity to go up as well. Okay, now let's move to supply, and again we note that for a given supply curve, if price changes, we just move along the supply curve, say from $4 to $3, and the quantity changes, but we don't need to shift a curve for a change in price, and we call this a change in quantity supplied. Okay, if something changes other than price that causes the whole supply curve to shift, then the curve will shift to the right or the left. In this case, we show an increase in supply, and note that at each price, suppliers are willing and able to sell more. Okay, and then here again we see the numbers underlying the supply curves that we looked at earlier. So for each price, we see that quantity supplied has increased as we move from S1 to S2. Okay, if we put our increases in supply along a given demand curve, we see that when supply increases, the equilibrium price will fall and the equilibrium quantity will increase. Okay, the last part of our question, what if supply and demand both change? Well, in this case, we know that the increase in supply and the increase in demand both lead to an increase in quantity. And in our example, the equilibrium price remains the same. Okay, we'll leave it to you to look at decreases in supply and demand instead of increases. In both cases, if demand or supply decrease, the respective curves shift to the left. Okay, other times we need to understand shifting supply and demand curves. We look at aggregate supply and demand, labor supply and demand, money supply and demand, supply and demand for foreign currency, and so on.
Now we've seen how to use the math behind the economics to understand what happens when supply and demand curves shift. Thank you for listening.